Hello, today we're going to talk about inequalities, specifically solving linear inequalities. Whilst watching this video, make sure you're making notes or have a pen and paper handy and write down anything that you think is important. Listen again, remember this is a video so you can rewind if something didn't make sense the first time. If you see the pause symbol, this is where I'm likely to ask you to do something, probably a small activity. Make sure you do that activity. It is there to try and make sure that you understand how this piece of maths works, and it's good practice. And finally, make sure that you are staying focused. Please try not to have any music, TV, or anything else going on in the background. It will only cause distraction. So, solving inequalities. Here on the left-hand side, as in there, this is an equation. It's two expressions joined together with an equal sign. Here and here, we don't have an equal sign. Instead, we have these things. These are inequalities. The middle one says that 5x is less than 45, and the one on the right is 5x is greater than or equal to 45. This might look a bit intimidating. It might be a little bit more difficult for you to understand what to do, but it's more or less the same as solving equations. Here, for example, if I've got 5x, I'm going to divide by 5 each time, which means that x is equal to 9. Here, I've got 5x is less than 45, but I'm still going to do the same thing. I'm still going to get 1x, which is less than 9. And the final one, I'm still going to do my divide by 5 on both sides, and get me x is greater than or equal to 9. Take particular care here. Notice that I haven't changed the sign in the question. If I started with a less than, I finish with a less than. If I have a greater than or equal to, I use that symbol each time. Do not change the sign. In every other respect, it is going to feel like solving normal equations. It is just a different sign in the middle of your work. So, okay, here we have two-step inequalities. For the first one, I'm going to do what I would normally do, and that is get rid of the minus 7. To get rid of a minus 7, I'm going to add 7 to both sides. That will give me 3x is greater than or equal to 30. Then, since I've got 3 lots of x, I'm going to divide by 3, which will give me x is greater than or equal to 10. On this second one, I'm going to start by getting rid of the plus 2. To get rid of plus 2, I'm going to take 2 away from both sides, which will leave me with x over 3 is less than or equal to 15. Now, some people will see 15 and 3 and immediately want to divide. Please don't. You have x over 3, which means divided by 3, a third of x. So to get rid of x over 3, we are going to times by 3 on both sides, which will give me x is less than or equal to 45. If you're working with brackets, same process, but I'm just going to start by expanding my brackets. That's my 4 times x. My 4 times minus 7 is minus 28. It's greater than or equal to 1. I've not changed it in any way. I've just expanded the brackets. Here, I'm going to add 28 on both sides. That will cancel out the 28, so it will leave me with 4x is greater than or equal to 29. Now, it's not going to give me a nice number, but I'm still going to have to divide by 4 on both sides, which will give me x is greater than 7 1/4. You could have also had 7.25. You could have also just left it as 29 over 4, depending on what the question said. Any of those answers would normally be acceptable. On this side, again, I'm going to start simply by expanding my brackets. That's my 2x, and my 2 times 1 is 2, is 13. I'm going to subtract 2, which gives me 2x is less than or equal to 11, and therefore x is less than or equal to 5.5, and you can write that however you see fit. With x on both sides, it's the same as normal equations again. So I'm going to look for my smallest value of x first. My smallest value of x is 2x because 2x is smaller than 5x. So I'm going to start by subtracting 2x from both sides. The reason we do this is simply so that we only have x on one side to make it more easy to solve. So I get 3x plus 6 is less than or equal to 3. Now I'm going to do what I normally do. I'm going to take away the 6, which will give me 3x is less than or equal to minus 3. And then my next step, on both sides, I'm going to divide by 3. I just realised I didn't write that in, which is a little bit naughty. There we go. There we go. So divide by 3 because I had 3x, leaves me with x is less than or equal to minus 1. Same on here, I'm going to start by taking the 3x from both sides, so I'll have 4x plus 3 is less than or equal to 23. I'm going to take 3 from both sides, which gives me 20. Therefore, x is less than or equal to 5. Reminder again that I'm keeping my sign consistent. Whatever I start with, I carry the whole way through. Do not change that sign. This part is slightly unique. You won't get this solving normal equations, but the process is the same. On this one, in the middle here, I've got x plus 6. I only want x on its own, so I'm going to take 6. And normally I would say take 6 from both sides. What I really mean here, though, is take it from all 3 different components. So 3 take 6 is minus 3. Less than or equal to, because that's the sign I have. X in the middle, just a less than this time, and 19 minus 6 is 13. So I know that x is somewhere between minus 3 and 13, but it can't be 13 because that's too big. On this one, in the middle, I have 4x, so I'm going to divide everything by 4, which will give me 2 less than x less than 5.5. There we go. And again, you can write 5.5 if you want to. Slightly more challenging questions because they're two-step equations, but it's still the same concept. Here, I'm going to start by taking 7, which will leave me with 0 is less than or equal to 3x is less than 12. I'm then going to divide by 3. 0 divided by 3 is 0. 3x divided by 3 is x. 12 divided by 3 is 4. This one, I'm going to start by adding 1. So I get 3 is less than x over 3 is less than 6. X over 3 means I'm going to have to times by 3 to cancel it out. 9 is less than x is less than 18. Okay, here are 6 questions. They are all from the previous slides you've just seen. So if you need to go back a few times, do it. And pause it while you're working, and then the answers will come up when you press play again. Okay, if you did those, here are your answers. Just to be clear, you should have divided by 3 to begin with. On this one, add 1, and then divide by 6. This one, you should have taken 2, and then divided by 5. This is a straightforward just divide by 2 because I have 2 lots of x. Take 1 to get rid of the plus 1. Divide by 2 to get rid of the 2x. And the final one, expand the brackets first, then add 3, and then divide by 3. You'll notice here I've left the answers as top-heavy fractions. There is nothing wrong with that. If you wanted to, you could write 2 and 2/3 and 3 and 1/3, or you could have 2.6 recurring and 3.3 recurring. I personally prefer to leave in top-heavy fraction because it's accurate. Finally, this is a common sort of worded question where you have to form your own inequality. Think about this very carefully as you do. What we have is John. He goes shopping and has £70 to spend. He buys 4 shirts and 1 pair of jeans. The shirts cost X, the jeans cost £38. Form an inequality. Okay, that means you're going to have one of those 4 symbols. You're either going to have that, or that, or that, or that in your answer. Now, the way I think about these is I'm going to write an inequality that says all the things John bought, which cost less than the money he has. So the things he bought, well, he bought 4 shirts. Well, he's 4, and we know the shirts cost X, so he's got 4X for his shirts. Each one of those is an X on its own. We know the jeans cost 38, so I'm just going to call that plus his jeans. So that's what he spent. He spent 4X and 38. And it cost less than the money he has. Well, we know how much he has. He has £70. Now, when you go shopping, you can spend up to the amount you have. In this case, he has £70. So he must have spent less than or exactly £70. Okay, so I can have the equals in there as well, like that. Then I would solve. Then that's the first part done. The second part is solving the inequality to find the possible price of the leggings. So we're going to do the same thing as before. I'm going to take what I had in the first part, and I'm going to solve it. I'm going to take 38 from both sides, which gives me 4x is less than 32, and that's come out very nicely if I divide by 4, as x is less than or equal to 8. Okay, that's how you solve linear inequalities. Good luck with the worksheet. Let me know if you need any help.